Hey everyone, welcome to this course. In this course, we're gonna create a CMP project. This CMP project has its own backend and frontend. For the backend, we're gonna use Ktor framework, which is a Kotlin backed framework. We'll learn how to use JWT Authentication token system to validate our user. We will see how to create API endpoints in Ktor backend. Apart from this, we're gonna also see how to connect our backend with Mongo database, which is a SQLite database. We'll see how to perform queries. We'll see how to update anything in our Mongo database, how to add it. We will see everything. Talking about the front end, as we already know, we use CMP. So CMP targets Android, iOS, desktops, and web. So we're gonna target all these platforms by writing only one user interface. In the front end side, we're gonna use Ktor client. We will use Koin dependency injection framework. Apart from this, we're gonna use here modular architecture. It is a multi-module project. That means you're gonna learn how to create modules and manage your project so that later on in future, if you want to scale your project, it will be very easy. We have few dedicated core modules for networking, for databases. Also, we're gonna use your local database, and this local database supports Android, iOS, desktops, and webs. So yeah, I'm very excited to teach you all these things. Welcome to this course again, and let's get started with writing our backend first. JWT Compose Multiplatform project, and usually I prefer Kotlin Wizard. It's a website that provides a template of Compose Multiplatform, and it is very easy to use Kotlin Wizard. For that, you need to open up your favorite browser. For me, I'm using Chrome, and just type for Kotlin Wizard in here. Just click on the first link, and this is the template, so you can use this template. So it asks you about information regarding your project. You have to give your project name, so I'm gonna give the project name as Note App. Project ID, I'm using developer Himanshu. Notes, let's select Android, iOS, and make sure in iOS you should choose Share UI via Compose Multi-Platform UI framework. And also we're gonna build this project for desktop and web apps, and also we're gonna write its backend. You have to use server for that. And it says with Ktor framework that uses Kotlin under the hood, which is very good. As a native Android developer, we are very much familiar with Kotlin, so it's very easy for us to write backend on Kotlin. Simply click on download. It start downloading a zip file for you that you can open up in your downloads over here. Just double click on it, scroll up. This is the project, and now we are going to open this project within our Android Studio IDE. So open Android Studio, click on this open, go to downloads and select the unzipped folder, which is Notes application. Click on open. It takes few moments to set up your project. Meanwhile, I'm going to show you the database which we are going to use. So I'll usually prefer Mongo database because Mongo database is a NoSQL database. It's very fast and very handy. Apart from this, it uses collection and documents to store our information, which is very much quicker if you want to perform any query. Apart from this, the real truth is this will give us a free tier, and we are interested in the free tier. So it's very easy to use. That's all. Now for that, open up your Chrome browser again. If you have any other browser, you will use that too. Just type for mongodb.com. First, you need to log in yourself. So do it. I'm gonna just click on the sign in Google. It takes few moments. Alright, so this is my dashboard, and I have already created one cluster for us. So each cluster has multiple databases, but Mongo database will only provide us one cluster for free tier. So I have already been created that cluster, so I'm not able to show you how to create a new cluster and how to create a new database. You will get a lot of videos floating around the internet. It's very easy, straightforward thing. It's not that much complex. So do it by yourself. It's very easy. We have the cluster, and this is my project. And when I want to connect it, simply click on this connect. We have a lot of options. And when you want to connect your Mongo database with your backend server, we'll use drivers. So drivers are nothing but a third-party dependency that help us to connect with our Mongo database. Click on it. These are the information, the URL. This URL is required in order to connect with your Mongo database. So simply copy it up. This password you will get when you create a new project within your cluster. This is the URL that we're gonna use to connect our backend server with Mongo database. Now come back to our project. Okay, syncing is done. So let me just show you the project structure. This is the Compose application. Just change the mode from Android to project. This is our Compose application, entry point for our front end. And this is our backend server. You can put all of your logic, all of your API calls, all of your microservices within this server. So main Kotlin application.kt contains main function, entry point for our server. We have extension, naming module over application. We have routing. We have a very simple path. Let me just execute it to see whether this server is working or not, or how you can use it. So for that, just click on this Compose application. We have various options in here. We have JavaScript, we have JVM for desktop, we have WebAssembly for website, of course, and lastly we have iOS. But we do not see any kind of option for backend. So what you can do, simply click on this play button, start working. Now just open this thing in Chrome. As you can see, Ktor Hello Java 21.0.6. Open Android Studio. You will see the message over here, and this greeting is present. Just control click on it within our shared resources. Shared module is a place where you should write all of your logic, all of your things which you want to share on the front end and on your back end. So this module is usually used to share the resources. That's why we call it shared module. Now let's discuss about this Compose application, or you can say the entry point of our front end. So source, we have various things in this. We have Android main. In Android main, you can write Android specific things. In iOS main, we can write all of the things which is specific for iOS. Similarly, for desktop, we'll use JVM main, and for website, we'll use web main. This common main is a place where if you write something, it is executable in all of your platform. As you can see, this is our user interface app, and this app is used in many places. So first, it used on the main activity over here. So this is for the Android main. Next we have main view controller. This is for the iOS. Control click on it, and this is for let me see where it is. Okay, so this is for the desktop applications, and we have one more place, and this is for the website, or you can say web main. So because we are using here Compose Multiplatform, we can very easily write Jetpack Compose UI, which is shareable, or you can say which is executable in all the other platforms very easily. So yeah, that's it. We have the front end, we have the back end in here, and now we are going to create modules because it's a multi-modular project. Talking about the modules, we have a few feature modules and core modules. So we have only two features, authentication feature and nodes feature. So let's create here modules. For the time being, Android IDE does not provide you any template that you can use to build a Compose Multiplatform module directly. So I am going to use here a custom approach, a very well manual approach that you should always use to create module, because it will never lead to you any typical error that you have never been seen in your career. Okay, new. We have here directory. So let's begin our journey with features. So we have features slash nodes slash data, and in nodes we have two more modules, or you can say for the time being directories, domain and UI. So we will use here clean architecture with MVVM principle. So clean architecture says we have to use three layers: data layer, domain layer and UI layer, and each layer has its own roles and responsibilities. So talking about the data layer is usually used to pull the data either from a local data source or from remote data source. Domain layer responsibility is to hold the business logic in a form of use cases, and these use cases will be used in our UI. And responsibility of UI is to present UI to our user. That's all. And in UI layer, we'll usually use view models just to survive the configuration changes. And we have various kind of scopes available within our view model, like view model scope, which we will deal it later on. But for the time being, just understand the roles and responsibility for these layers. Okay, now we are done with the nodes. It's time to begin our journey for auth. So in auth, we have three again. We have data layer, we have domain layer, and we have UI layer. Next, we need to write its build.gradle.kts file because each module has its own build.gradle.kts file. So build.gradle.kts. Make sure to use the exact same naming convention that I'm using because you can't play with this naming. Now simply open up your compose application build.gradle.kts and I'm gonna copy this whole stuff, come back to our authentication data layer build.gradle.kts and simply paste it. Now in this build.gradle.kts we need to change few things. First, let's remove the main class because we have only one main class for desktop, and in this I want to use here nodes features auth data. This is my package name. Copy this stuff, scroll up, and in the namespace just simply paste it. And yes, we are done. I don't think so we have multiple application ID because it act as an Android library. Version name doesn't matter at all, and the rest of things looks fine to me. Yeah, it is. Scroll up, and we are not going to create multiple frameworks for iOS, so just cut this thing from here and paste directly. And yeah, I think we are good to go. We need to change one more thing because as I told you, this is not an Android application, it's an Android library. So just use here Android library. Let me show you the dependencies. So we'll use here libs version toml file, and here you can see we have Android library. I just copy this Android library and paste in here. Now scroll down, open up your settings.gradle.kts, and we need to mention this module information over here. So to do that, just duplicate it. We have here features auth data. Sync this project. You will see everything changes once the sync is completed. Okay, need to remove this comma and just try again. Let me import these things. So just add this import and retry it. Alright, so now when you open the features, you will see the data directory changes completely. Now I want to copy this and paste within my domain. Just need to change the package name for desktop and namespace for our Android. Scroll up, make sure you have imported everything. Yes, we are. Now scroll down, go to settings.gradle.kts, duplicate it, do the same thing for domain and sync this project. Okay, so domain layer is also working. Now just copy this stuff. In the UI need to create a file and the file name is build.gradle.kts. Paste it, change the package name from domain to UI, scroll up, change the namespace for Android from domain to user interface. And now I'm going to do the same thing for my nodes. So just copy this stuff, paste in our data, scroll down. In the desktop package name, just change the nodes to authentication to nodes data. Scroll up, in the Android namespace, do the same thing, nodes data. Copy this stuff, just create a new file within our domain build.gradle.kts and paste it, change the name from data to domain. Similarly goes for the Android namespace from data to domain. Now again copy this stuff for the UI, create a new file and the file name is build.gradle.kts. Paste in here, change the name from change the package name from domain to UI and namespace from domain to UI. Now scroll down, open up settings.gradle.kts, duplicate it, add UI module information. Similarly for the nodes data, then domain, and lastly we have UI. Sync it. Alright, syncing is done. As you can see, we have authentication feature and we have the nodes feature. Now it's time to create few core modules. So for that, just right click on it, directory, we have core network, and we have core database. One more, we have core for authentication. Now similarly, I'm gonna copy the build.gradle.kts from the nodes data layer and paste within our authentication, within our database, within our network. Scroll down, change the name. So first we'll change the package name from authentication to core network. Similarly goes for the Android namespace. Remove this feature nodes data, just use here core network, and make sure do not use underscores in your package name or in your namespace. Open the core database and do the same thing. Core database. Scroll down, do the same thing over here. Open the core authentication build.gradle.kts and do the same thing. Just call it core auth. Core auth. Now it's time to attach these modules in our project. So duplicate it. We have core network, we have core authentication, and we have core database. Sync it. Alright, so you're pretty much done with the module creation. Now we have a few core modules and 2 feature modules. It's time to attach the dependency that we'll consume in this project. So I have simply copy paste that information within our project. You can open libs version toml, and this contains all of our plugins and the dependencies information. I'm gonna simply paste the information, the dependencies that we're gonna consume in our project, and here it look like. Sync our project, scroll down, and I'm gonna explain you dependencies that we wanna consume. So first dependency is for Koin. Next we have Ktor dependency for server and client. We have serialization, we have content and negotiation, navigation. So this navigation help us to perform navigation within our Compose Multiplatform project. We have Mongo driver which help us to connect with our MongoDB database very easily. We have preferences data store because we want to save that bearer token on our front end. So to do that, we need to use this third party library. For the time being, we do not have something which support all of the platform. Yes, we have preferences data store that support Android, iOS and desktop, but it doesn't support our WebAssembly. Alright, so this is what we have in our dependencies. Now let's begin our journey from server side. So first we're gonna write our endpoints for authentication, like for login and registration. But before that, we need to connect our server with Mongo database. So let's do that thing first. So to do that, open up your server, source, main, and in server we wanna use clean architecture. So to do that, we need to create 3 layers. We have here data layer, we have domain layer, and we have here presentation layer. In server, this presentation layer is used to communicate with our client. That means in presentation layer we have DTOs, and as I said to you, DTOs are those objects which usually used to send information from server to your client. That type of objects is called data transfer object, and because our client when try to communicate with our backend, presentation layer will be the point of contact, and that's the reason why we should put all of our data transfer object within our presentation layer. Now we are going to add dependencies in our build.gradle.kts of our server module. So implementation libs Ktor. First I want to add here serialization. Next I want to add authentication dependency, and in authentication we have a lot of mechanism through which we can protect our APIs, and on that mechanism one is JWT, JSON Web Token, and we want to use that JWT token mechanism to protect our APIs. JWT.jvm. Next, we want to use here JBCrypt. So JBCrypt is a third-party library which help us to encrypt and decrypt the password, or if you want to do any other encryption decryption, you can use it. But mostly for this project, I want to use JBCrypt to encrypt and decrypt the password, because we cannot directly store the user password in our Mongo database. We want to encrypt that password and store it on database, and once user wants to log in, we fetch that information, encrypted password, decrypt it, and verify it whether the passing password and the Mongo database password matches or not. So this matching is also happens by this library. So this is a use case of JBCrypt. Next, we have implementation Mongo driver. So this Mongo driver act as a driver, help us to communicate our server with Mongo database. And Mongo database is a NoSQLite database, uses collections and documents to store our information. For the time being, these are dependencies that we need in our server side. Sync it, and at the top make sure to add serialization plugin. And I might forgot this one, content negotiation. Ktor content negotiation. So content negotiation is a plugin that we need to install in our Ktor server if you want to communicate with our client with JSON format. If you remember, in the client side or in Android, when we want to use Ktor client, we'll install content negotiation and specify it that we want to use JSON in order to communicate with our server. The same thing we want to do on the server side with Ktor framework. Think it again, and we are pretty much done with the dependencies part. Alright, so we are done. Now let's begin our journey with domain layer. Now in this domain layer, as you already know, we have a few domain layer models. And for the time being, we have three. First, we have a user credentials. This user credential information coming from our client side. So we have two things, email and password. We have a data class, and the data class name is token. This is a return type of our registration and login use cases. I want to create one more data class that is used for user, and I want to call it user. And in this user, we have three parameters: ID, then we have its email, and lastly the password. Now in domain layer, I want to create my repository. Repository name is user repository. It's an interface, and in this interface we have two functions: get user by email, just pass the email, and the return type of this function is user. So we want to fetch user from the email from our Mongo database. Sometimes it might happen that there will be no user present in our Mongo database. On that scenario, will return null. That's the reason why I make this thing optional. And next function is create user. So if you want to register your user, this function is utilized by our use cases. Alright, so we are done with our repository interface. Now it's time to write its implementation within our data layer. Now in this data layer, let's create a package naming database. This database package contains all of the information, all of the logic that you want to use to communicate with your Mongo database. Or also it contains all of the information which we want to use to initialize or establish connection between our server and this Mongo database. Let's create here an object, and the object name is MongoDB. And I need one more object, and the object name is collections. As I told you, Mongo database is a NoSQLite database. It uses collections and documents to store our information. Now we have two collections. So first one is user collection, and next is notes collection that we'll use later on. In Mongo database, we are going to write the logic which is used to establish connection between our server and Mongo database. So we'll need here URL. For the time being, just use empty. Next we have client, and this client is coming from our driver kmongo create client, pass the URL. Now lastly we have the instance of our database, and I want to call this MongoDB. Use our client dot get database, and you need to mention the database name. In my case, my name is note taking app for YouTube. Now I want to replace this empty URL with my URL, which is this one. By the way, you can get this URL from your MongoDB. This is my Mongo database dashboard. This is the cluster, and in this cluster I have already created one database. Click on this connect driver. This is the URL that you are looking at. In the DB password, when you start creating this database, at the starting you will notice it pops up an information that contains two things: your username and your password. So you can grab this password, copy, paste it somewhere securely, and then use it. This is the URL that I am using in my URL. So we are done with this MongoDB. Now it's time to write the repository implementation. A repository package has a class, and the class name is user repository implementation. It's a class that uses our user repository. Now private variable collection, and I want to initialize it lazily. We have our MongoDB. Import this MongoDB. Mongo database get collection, and the collection is user entity. Let's create user entity in our data layer. So for that we have a package naming model, and in this model we have our user entity. It's a data class that has ID, email, and password. Type is string. Because this ID is generated by our Mongo side, will usually use object IDs. So to tell that this is a MongoDB ID, we'll use boson ID, import it, and at the top make it serializable and reserializable, import it. Alright, this is my user entity. Now let's use it in our user repository implementation. Collection type, mention the user entity, import it. Now get user by email, just leave it. Let's finish this create user first. So we have the collection information, and in this collection information I want to insert one user entity, and in this user entity, in place of ID we'll use object ID to string. In place of email we'll use the user email. In place of password we'll use user password, and that's it. Now get user by email, we'll use our collection. We have here find one user entity email equates with the passing email. If it is a case, and if it is not null, that means we have the user entity. We'll simply just map this user entity with our domain layer user entity ID, user entity email, user entity password, and return it. Alright, so we are done with our user repository implementation. Now it's time to provide this thing. So in data, let's create a package for dependency injection that has a file, and the file name is data module. Get data module. Return type is module. Make sure this module is coming from Koin. Okay, so I didn't add Koin dependency in our builder.gila.kts, so let's do that. Duplicate it, use Koin here, and sync our project. Go back to the data module.kt, and now it is available. See, module coming from org.koin.core.module, so use it. Return module, and in this module I want to create here a single instance of our user repository, and implementation is user repository implementation. we are done with this data module, and we have already done with the user repository implementation. Now it's time to write use cases. But before that, we need few utility functions. For that, I want to create a new package naming utils, and in this util, the first utility function is JWT configuration. JWT config, it's a class, and in this class we have secret. So first we are going to create here an algorithm, and this algorithm, make sure, is coming from com.auth0.jwt.algorithm. In this we have HMA C256. Usually most of the developer prefer this algorithm, but if you have any other approach, any other algorithm that you want to use, you can go with it. It's not mandatory to use that what I'm using right now in this project. Pass the secret, and next we have verifier. Import this JWT. This JWT is coming from this dependency, this one. Next I want to create a function naming generate token, and in this generate token, just pass your email. Use jwt.create and attach the claim. So for the claim, let's create here a companion object const while naming email. And in this claim, we need to pass two things, the naming. So naming is email, and value, which is email. And I want to sign this thing with my algorithm. And that's it. If you check out this type, it's string. Return it and make the return type is string. Okay, so we are done with this function. This JWT configuration takes secret input and uses that secret in our algorithm. This algorithm is used to generate our token, but in that token we have a claim. So claim means this information is encapsulated, is present in your token. I want to store my email information in the token so that we can very easily use it in other places. Like if I want to get this email information in my notes or notes routing, we can do it very easily. That we will do later on in this project. But for time being, just understand this claim is something that is present in your token in encrypted form. Next, we need to create utility module in order to provide this JWT token so that we can very easily inject it in our project. So for that, let me create here a file, and the file name is utility module. Function get utility module. Type is module. I want to return this thing. It's a single instance of our JWT configuration. We need to pass secret. So let's create secret within our JWT configuration companion object. Call it const while secret, and just type some gibberish. Come back to our utility module and use it. JWT configuration secret. But if you are working on some real project, never do this secret injection like this. You can create some environment variable or anything else that is more secure comparing to these things that we are doing right now. This is entirely wrong. Never do it. Use environment variable to inject this information. Okay, now it's time to write use cases. So in our domain, let's create package use cases. So first use case is for registration use case. It's a class, and in this class I want to inject two things. First, JWT configuration just to generate the token. Next, the user repository. We have here suspend operator function invoke, and in this we pass the user credential, and return type of this function is result of type token. Import this token, make sure it is coming from our domain layer. First thing first, we need to check. So if our user repository dot get user by email user credential email, if it is not equivalent to null, we simply use result dot failure and pass the exception, and in exception says user already registered. If it is not the case, we'll generate hash from the password. Now here we'll use bcrypt. As you can see, my AI is already suggesting me to use this one. So let's accept this suggestion, import it. Now what it do? It simply take our password and a salt. This salt is used to encrypt this password. And at the end, we have the encrypted hashed password within this variable. Next, we want to create instance of our user. In this user, we have three things: ID. So ID is object ID, toString, email is coming from user credential dot email, and in place of password, we'll use hash password. Now use user repository, create user, and simply inject this user. But if you check, the return type is result of type token. So let's generate token here. So for that, we'll use JWT configuration dot generate token. You can simply pass the user credential dot email, and we have that token. Now I want to return it. Store it in variable naming token, and at the end we'll use result dot success and pass the token. Return it, and that's it. We are done with our use case. So this use case, first check if the user is already present in our Mongo database. We simply return user already registered. Otherwise, we'll encrypt the password, create a new instance of our user, insert this information in our database, generate a token, and return it. This is my use case for registration. Now I want to do the same thing for login, but in login things are slightly changed. So login use case. In login use case, we have two things. First, we have JWT configuration, and next we have the user repository. We have suspend operator function invoke. User credential is coming, and return type is same, result of type token. So first we fetch the information of our user entity. We have user repository dot get user by email. Use our user credential dot email. If user entity is null, that means we do not have this user in our database. Simply use result failure and send an information user not found. Now we will check if our bcrypt dot check password, and in this we have to pass two things: the plain text. So this plain text is coming from our user credential, and next we need to pass the hashed password coming from our user entity dot password. So if it is not true, then simply use result dot failure and pass the message invalid password. And in the failure, we must mention the type, which is token. So if it is not the case, we'll simply generate a token with the help of our JWT utility configuration. JWT config generate token, pass the email, user credential dot email, and at the end we'll return it. Result success token, and in this token simply pass a token. That's it for our login use case. So what we did here is we first grab the information of our user entity. If user entity is null, that means user is not registered yet on our server. So we'll return this failure information. And next we'll check whether the plain password or the user password matches our database Mongo database password or not. So if it is not matching, we'll return here invalid password. If it matches, we'll generate the token and return it. This is my use case for login. So we are done with the registration use case and login use case. It's time to create here DI module within our domain layer. So DI, and I'm gonna call it domain module. It's a file get domain module, return type is module. Make sure module is coming from our Koin core module. Return module, use here factory, and in this factory login use case, import it, pass the JWT configuration and the user repository. Similarly for the registration use case, Alright, so we are pretty much done with this domain layer. In this domain layer, we have our user repository interface. Implementation is given by our data layer. We have our use cases, login use case and registration use case. We have issue here. Let me check why. What's the issue? Okay, so in the failure, we need to mention the type, and the type is token. So now we are 100% done with our domain layer for authentication feature. It's time to jump in our presentation layer. Next in our presentation layer, we have route handlers, which help us to handle the incoming request. So for that, I want to create here a package, and the package name is routes. And in this route, for the time being, we have only one route naming auth routes. It's a file, and we have extension function over route. Call it auth routes, and in this function we need to pass our use cases, like we have login use case and registration use case. Now we are going to use here route. So route is authentication, and in this authentication we have mechanism to register and login. So for registration, I want to create here a post HTTP method that has the endpoints like register. So first we'll retrieve the information of our user credential from this call. So user credentials call receive, and type is user credential. This information will be provided by our front end. We need to use our use case. So for that, we'll use registration use case, invoke it and pass our user credential. On success, we'll receive the token information. Use call and respond back with HTTP status code created, and we need to pass this token. Just pass the data. We need to mention this type, and the type is token. Import it, and we are done for the success case. Now what will happen if we receive error? In that scenario, we'll use call and respond back. Status is HTTP status code dot conflict, and in the message we'll use our error dot message to string. So that's it. This endpoint is used to register our user. So if you check out its logic, it's very simple. We first retrieve the information of our user credential that user passes from the front end. Next, we'll use our registration use case, pass this user credential, and all of the logic of creating and checking all of the things will be happening within our use case. When we get the success response, we have this callback on success, and we'll respond back with the token that we receive from our registration use case. And if something goes wrong, we'll eventually end up in this callback on failure, and we respond back with that message. This is my registration. Now for the login, again I want to create here a post HTTP method /login. We have the user credentials information from our call. So call receive, type is user credentials. Next, use login use case, invoke it, pass your user credential. On success, we have the token information. Use call, respond back with HTTP status code dot OK, and return back the token information. On failure, we'll use call and we'll respond back with HTTP status code dot unauthorized. So if you want to use any other status code, you can use it, but unauthorized seems very good to me. And next we need to pass the message. So simply use it dot message dot to string, and we are done with the auth handlers. So in this auth handler, we have two authentication handlers. First one is used to handle the registration process, and the second one is used to handle the login requests. And now it's time to use this authentication route in our application. But before that, we need to install authentication system in our Ktor framework. So to do that, in our utility function, I want to create here a new file, and the file name is configure authentication. Create a function which is an extension over our application, and name is configure authentication. Pass the JWT configuration, and I want to install authentication system. Just use authentication. As you can notice here, this is coming from IO Ktor server.auth, which is perfect. Now within this, we want to use JWT authentication token mechanism. Use JWT, and in this JWT we need to configure the verifier and how we validate whether the token is genuine or not. So as you can see, my AI suggested me to add verifier. So just use it, and this verifier is already been created within our JWT configuration. Next, we need to validate this token. So for that, we have a function naming validate, and in this validate, we'll have the credentials information. And if you notice in our JWT configuration, we are using email as a claim. Now we can get this information within our configure authentication function. So in order to get that information, we'll use here email naming variable credential dot, and in this credential we have payload information. Just use here get claim. We need to pass the name, and if you remember, the name is email, and I want this information in a form of string. It's a very straightforward thing, but if you are doing this thing for the first time, it might look little bit more complex, but it is not that much complex. It's very straightforward thing. I want to use the suggestion, import this JWT principal. So here you can see if our email is not null, that means we have the payload information on that scenario. I wanna create an instance of our JWT principal that contains the information about our payload, else we use simply null. Now just open this validate. If you notice, it's lambda, so it's an extension over application call. Input is JWT credential that we are receiving here. Next, the return type, which is any. Any means you can use any type of object like string, integer, long, totally up to you. So I'm using a string. So we return JWT principal that contains information about our payload, and we can access this information anywhere where we want to protect our APIs. We can get this JWT principal and use email queries. We will use JWT principal to get the information about the user email. Alright, so now we are done with the configure authentication. It's time